Hello, in today's video we are finishing up our section on trigonometric integrals. And so today we're going to learn how to solve integrals that are products of powers of secant and tangent. And we're also going to do integrals that are products of sine and cosine where the inner function is not the same. It might be multiples of x or multiples of theta. So the first thing we're going to talk about is here are some guidelines for evaluating integrals with powers of secant and tangent. And so there are 5 of them. We're going to go through an example for each of them. So today's video might be a little longer than normal. I apologize. So our first rule is when we have powers of secant that are even and positive, what we're going to do is we're going to save one of those secant squared factors and convert the remaining factors to tangent, okay? So if I have even here, I'm going to convert an even number of them to tangents and keep one of those tangent squares here. The next rule is when the power of tangent is odd and positive, then we're going to save a secant tangent factor. So here's our secant tangent factor that we're going to save and convert the remaining factors to secants. So then I convert all the rest of the tangents to secants, okay? And the third rule is when there are no secant factors and the power of tangent, so no secant and the power of tangent is even and positive, we're going to convert a tangent squared factor to a secant squared factor. So basically we peel off one of those tangent squareds and convert that to our secant squared minus 1. Our last rule is when we have an integral of the form just secant to some power, where it's secant to an odd power, then we're going to use integration by parts, okay? And so we did this last time when we had secant cubed x back in section 8.2, so you can refer to that for that example. And then our last one is when the first 4 guidelines do not apply, try converting to sine and cosines and then evaluating it that way. So we're going to do an example of all of these cases except 4 because we've already done an example of that. Okay, so sorry about that. So our first example here is to evaluate the integral of tangent cubed x divided by the square root of secant x. So here I'm going to look and I'm going to say, okay, tangent is odd and positive. So I am in case number 2. And so in that case, I'm going to go ahead and convert my tangent cubed to tangent squared times tangent. So, and I'm going to rewrite the square root of secant as secant to the negative 1/2. So I have secant x to the negative 1/2. And then I'm going to split that tangent cubed into a tangent squared and a tangent. Then the next thing I'm going to do is I'm going to take that, so let's see here, what did I do next? My goodness. Oh, I see. So the next thing I'm going to do is I am going to go ahead and peel off an entire secant off of that secant to the negative 1/2. So I'm going to rewrite that as secant to the negative 3/2 times secant of x times tangent of x times tangent squared of x. And so the reason why is because I want a secant tangent factor. So now I have secant of x to the negative 3/2 times tangent squared times a secant tangent factor. And then I'm going to change this secant squared to secant. So now I have secant x to the negative 3/2 times secant squared x minus 1 times, and then secant x tangent x. And so then if I go ahead and distribute this, now I have secant x to the 1/2 minus secant x to the negative 3/2 times secant x tangent x. And then if I let u equal that secant x, then du dx is going to be secant x tangent x. And so then I'm going to have an integral of u to the 1/2 minus u to the negative 3/2, and then that will cancel du. And so once I do that, then I can go ahead and integrate, and I will get u to the 3/2 minus u to the negative 1/2 divided by negative 1/2 divided by 3/2. So then I'm going to end up with 2/3 secant to the 3/2 plus 2 times secant to the negative 1/2 plus c. All right, great. Our next example, we have secant to the 4th 3x times tangent cubed of 3x. And so for this one, we're going to go ahead and split that tangent squared up, or the tangent fourth into tangent squared times tangent squared, or secant squared times secant squared, excuse me. So secant squared of 3x times tangent cubed of 3x times secant squared of 3x. And so what I'm going to do now is I'm going to switch this secant squared to a tangent squared and distribute. So I get 1 plus tangent squared of 3x times tangent cubed of 3x times secant squared of 3x dx. Then I'm going to distribute that tangent cubed, so I get tangent cubed of 3x plus tangent to the 5th of 3x, and all of that gets multiplied to secant squared 3x. And then I'm going to let u equal tangent of 3x, which means that dx is going to be 1 over 3, and derivative of tangent is secant squared 3x. Okay, so we got a little chain rule going on there. Du, which is going to cancel this secant squared at the end. So now my integral is 1/3 u to the 3rd plus u to the 5th du, which then is going to give me 1/3 u to the 4th divided by 4 plus 1/3 u to the 6th divided by 6 plus c. And put it all together, we are going to get tangent to the 4th of 3x over 12 plus tangent to the 6th of 3x all over 18 plus c. All right, so the whole goal is to make sure that you leave a factor that is the derivative of whatever you have over here. And so by following those rules of the odds and the even powers of secant and tangent, that is what's going to help you figure that out most efficiently. All right, our next example, we have a definite integral from 0 to pi over 4 of tangent to the 4th x dx. So this one we have no secant factors. So what we're going to do is we're going to convert one of the tangent squared factors to a secant squared. Sorry about Philip. All right, so the first thing I'm going to do is go ahead and rewrite this as tangent squared times tangent squared. And then I'm going to convert that one of them to secant squared minus 1. So 0 to pi over 4, tangent squared. And then I have secant squared x minus 1. Then I'm going to go ahead and distribute. So tangent squared x, secant squared x minus tangent squared dx. And then I can separate that into two separate integrals. And then when I do that, I can let u equal, for the first integral, that first integral, we're going to let u equal tangent of x. So then the derivative of tangent is secant squared. So then I could figure out that dx would be du over secant squared x. So that's going to cancel. So then this one is really the integral of x equals 0 to x equals pi over 4 of u squared du after things cancel. And then this one over here is an even power of tangent again. So we're going to go ahead and convert it to secants. So I get secant squared x minus 1 from 0 to pi over 4. And so then now this integral is going to be u cubed over 3, but u is tangent. So tangent cubed of x over 3. And then over here, the derivative of tangent is secant squared, so the integral of secant squared is tangent of x. And then we have minus a minus, so plus x, and we're evaluating all of that from 0 to pi over 4. And tangent of 0 is 0, so really I just need to plug in the pi over 4. So I'm going to get a third minus 1, and then plus pi over 4. Plug it into my handy dandy calculator, and we get 0.119. All right, 2 more examples. So our next one is secant x over tangent squared of x. If I look through all of my rules for powers, I do have an even power of tangent, but it is not positive, so we can't use that rule. So this doesn't fit any, so our plan here is to change to sine and cosine. So really this is the same thing as secant of x times cotangent squared of x. And then if I convert those, I get 1 over cosine of x times cosine squared of x over sine squared of x. Then I can go ahead and cancel, so I have cosine of x over sine squared of x dx. And then if I let u equal sine of x, since I have a factor of cosine, then I'm going to see that dx is 1 over cosine of x. So that will cancel. So then I have 1 over u squared du after I do my substitution there. And then, so that's u to the negative 2. So add 1 to my exponent, divide by my new exponent. I have negative u to the negative 1 plus c. And go ahead and factor in my substitution of sine. So sine to the negative 1 is the same thing as cosecant. So I have negative cosecant of x plus c. All right, our last example is not involving secants and tangents. Our last example is a product to sum. It's using the product to sum formulas. So if we have products of sine and cosine that have different inner functions that are just multiples of each other in some form, we can go ahead and use these product to sum formulas to help us change them into an integral that we can do more easily. So our first example is sine of 5x times cosine of 4x, and we're finding that integral. So if I look at my product to sum formula, I have the second scenario here. So this is the same thing as the integral of 1/2 of sine of 5 minus 4x plus sine of 5 plus 4x dx. So then if I go ahead and simplify that, I have 1/2 times the integral of sine x plus sine 9x. And if I go ahead and integrate, I am going to get negative 1/2 cosine of x plus, let's see here, cosine of 9x divided by 9 plus, I also have to multiply that 1/2, so 18 would be my denominator there, plus c. So those are also some helpful formulas. All right, go ahead and try your homework.